Okay, hi. Welcome back. So we are on the distributive property, lesson 1.3. Again, you should have your notes out, and you should be getting those set up. You can be writing the title down on your notes. And today you have another IXL lesson to do, 8.3. And again, you can access that a couple of different ways directly from the calendar. You can just click on the link, but again, make sure that your name is in the corner. So I want to know, do you see your name? All right, so you want to see your name in the upper right-hand corner. And then remember, your goal is to get an 85. That's all. For the SMART score, your goal is an 85. But you can stop whenever you want to. So if you want to stop at 75, fantastic. If you're like, this is super easy, I can get 100, then get 100. Extra credit. Way to go. So it's all up to you. And remember, it is by Sunday. I know the previous video was a bit lengthy. Sorry about that. Again, it's early. I'm just trying to make sure everybody understands everything they need to know. Hopefully this one will be a little shorter. So first, we want to talk about some properties of addition and multiplication. So these are common properties. I'm pretty sure this is like an 8th grade or maybe a 6th grade standard. So hopefully you've seen these before, but I think it's so important to go over them again. We have the commutative property. The commutative property is the fact that we can change the order of numbers. So the commutative property of addition says if I take 5 plus 4, it's the same as if I were to reverse the order. So it's equal to 4 plus 5. So the order in which we add two numbers together doesn't matter. For the commutative property for multiplication says the same thing, that the order that we multiply two numbers doesn't matter. 3 times 7 is going to be the same as 7 times 3. So the order that we multiply or the order that we add things together doesn't matter. The same is not true for subtraction and division. The order absolutely matters on subtraction and division. So these properties are very specific just for addition and multiplication. Now subtraction, we can actually tweak that just a little bit. Because we can do -5 plus 4 is the same as 4 plus -5. So you can actually tweak it just a little bit. This is kind of a subtraction problem, but really it's just addition. Everything is just addition. Okay. Associative property says that our associative groups, how we are grouping symbols, how things are associated, we can change those associative groupings and we're still going to get the same result. So for instance, if I had 3 plus 4 and I had some parentheses on there, some grouping symbols that tell me, hey, you need to do this addition part first. Well, 3 plus 4 is 7. Then we can do the plus 5, we get 12. Well, it turns out that it would be the same as if I changed those associative groups. So if I did 3 plus and then 4 plus 5 in a group, so now this right-hand side says, hey, look, if you add the 4 plus 5 first, because that's what grouping symbols mean, do me first. So 5 plus 4 is 9, plus 3 is 12, and these two things are equivalent. The same is true for multiplication. 2 times 3 times 4. 2 times 3 is 6. Times 4 is 24. Would be the same as 2 times 3 times 4, where we want to multiply the 3 times 4 first. So 12 times 2. Why do we need to know this? Well, really, it's for when we simplify things, mostly when we're using our brain. Because we're better at certain products. So if I happen to know, hey, I can multiply by 2 really, really easily, then usually if I can multiply the larger numbers first to get like 3 times 4 is 12, that's a larger number. Then to just double that is a lot easier, maybe this time. Okay, so just being able to reorganize things to add or multiply things the easiest way possible. The identity property for addition says if I take a number like 7, identity, thinking identical to itself. So if I take a number like 7, what do I have to add to it so that I get an identity? Whatever I started with is equal to whatever I'm ending with. Well, what do we have to add? 0. That's the identity. We can add nothing and we'll get the same thing. So adding 0 doesn't change anything. That's kind of nice. Well, what is the identity property for multiplication? Well, same idea. Let's say I have 9. What can I multiply by so that I get the same thing? I get 9 again. 9 times what? 9 times 1. So those, so that whatever you start with is the same as what you end with. Whether you add a 0 or multiply by 1, those are identities. All right, inverse operations. The additive inverse is what can we add to a number so the inverse happens, meaning it undoes it. So if I have like a 5, what can I add to it so that it cancels out, so that it goes away? And of course, we use the inverse properties all the time when we're solving equations. So this is why this is important. How do I take that 5 and morph it into a 0? What can I do? What can I add to it? Well, I can add a -5. Positive 5 and -5 are inverse operations. Positive 5, -5, inverses, okay? And they result in a 0. The multiplicative inverse says if I have, I'm going to use a fraction. So I'm going to use, if I have 2/3, what can I multiply to it so that it multiplies and sort of reduces itself away? And it doesn't go away particularly. It becomes a 1. It turns into a 1. So 2/3 times what would give me a 1? The multiplicative inverse is also known as the reciprocal. So 2/3 times 3/2 is the inverse operation. And you can see if you were to multiply these fractions together, 2 times 3 is 6, 3 times 2 is 6. So this is 6/6, which reduces to 1. And so these end up reducing down to 1. And 1s are really, really nice when we're trying to solve equations. So this is the multiplicative inverse. You can think about it as like a reciprocal. I'm going to use that word all the time. It means flip the fraction. So even if you had 2 times what would give you 1? Well, if you had a 2, you could multiply by the reciprocal, which would be 1/2. Remember, this is 2/1. You flip the fraction, it becomes 1/2. 2 times 1/2, well, that's just 1 whole. And so we're going to use the reciprocal a lot, and that is the multiplicative inverse. And then the distributive property, the actual property looks like this. It says A times the quantity B plus C. Well, sometimes it looks like this. The distributive property says that if you have a number outside as a grouping symbol, then you can multiply that number to both objects inside the parentheses. So that becomes A times B plus A times C. I'm sorry, A times C. And, well, so I don't like giving you properties like this. So in the book that I'm using, all of these things that had numbers were just done with letters. And I don't like that. You won't see me do that very often. So I don't do stuff like this very often. I will only hold it out there once or twice at a time because I think you can make sense of things fine with numbers, knowing that I could use lots of different numbers instead of just 4 and 5. There's a whole lot of numbers out there. So to show this, we could do, well, you'll see it probably in the next couple of examples. So I'm just going to leave that. Like the next example. Here we go. Again, it would be really helpful when you're taking notes if you had your highlighter right by you so that you could be taking notes. You're writing the directions. Remember, you must have example 1 and the directions because that's the most important part, believe it or not. You can't do math without understanding what you have to do. What's the goal here? Our goal is to simplify the expression. So we have a few problems here. So I was going to say, I didn't finish. You got your highlighter. If you would highlight these example 1 directions and example 2 directions, highlight those things for me. That's going to make grading them so much easier. And remember, you are going to have to come during office hours towards the end of the unit. I'll let you know when that is, but you're going to have to show me your notebook, and you're going to have to just hold it in front of you and turn the pages for me. It'll be pretty low key, but we'll see how it works. See if I need to do any adjustments here. We have 3 times the quantity x plus 5. So this is utilizing the distributive property. It fits that same sort of pattern we were just looking at. So this is distribute. I want you to use that word. It's important that when you're doing math, talk out loud. Tell yourself the steps to do. It's really, really helpful. So the first thing we want to do is we're going to distribute the 3. And so we're going to take that 3 and we're going to multiply. Distribute just means multiply it in. Multiply it inside. All right, so we're going to multiply 3 times x plus 3 times 5. Well, 3 times 5 is 15. This is simplified. This is a great answer. We usually don't use the little dot to represent multiplication, so we would just simplify that and say 3x plus 15. This is it. These are not like terms. This has an x in it, and this doesn't. Therefore, they're not the same. You can't combine them. You can't do anything else. These are 2 separate terms. First term, second term. Now, is letter B a distribute problem? What's different? They look so similar. The big difference here is this big glaring plus sign. The plus sign is next to the parentheses. Oh, well, that's telling me this is addition. Here, there was no sign between the 3 and the parenthesis. Well, in that case, there's a hidden multiplication symbol. So that's really, really important. This is just addition, and I don't really need to distribute a plus sign. That doesn't make any sense. So really, these parentheses aren't very helpful here. So I can just sort of drop these parentheses. And you can see that this is just combined like terms. And so again, if I'm writing it down, you should be writing this down. So what are like terms? Like terms have to have the exact same variables. The same powers on the variables. All the variable parts need to match. So anything with a plain old x, that's one type of term. So there's always a little invisible 1. If you don't see a coefficient, a number in front, then it's a 1. So we have a 1x. And then we see these plain old numbers. So we have a positive 3 here and a positive 5. And we want to combine those together, and a positive 3 and a positive 5 make a positive 8. And it is important that you separate your terms. You should always have a sign in between a positive or negative. In this case, it's positive. Because if you didn't have it, if it was x8, well, first, that seems weird, doesn't it? But maybe you wrote it 8x. That doesn't seem so weird, and it means something entirely different. This means 8 times x, and that is definitely not what we want, okay? So this is a great answer. It would also be equivalent to write 8 plus x, and that also works too. They are the same thing. Remember, the commutative property says that we can switch these orders around. In addition, it doesn't matter. So x plus 8 is the same as 8 plus x. Here again, we see the difference between these 2 problems. One of them uses the distributive property and one of them does not. So again, this is a -4 times this whole group. So this is the distributive property. And this time we're going to distribute a -4, which is a little more complicated. So you want to take your time and really make sure you understand this. And again, if you have questions, write them down, highlight it, put a big question mark, write a question so you can ask me on Tuesday or at the end of the day. So we're going to go ahead and multiply in that -4. And so we're going to do a -4 times the c plus a negative 4 times the 2. And I hate doing it this way. I'm never going to do this again, okay? So we did negative 4 times 2. And you'll notice the problem. I brought down the plus sign, but now I have a plus, a negative, and I hate double signs. I will never do this. I'm going to clean it up. Negative 4 times c, we usually are just going to write them right next to each other without the little dot to represent multiplication. And then over here, you should never have double signs, not at this level. Positive times negative is negative. 4 times 2 is 8. This is a great answer, but again, I hope you do not do it that way. What I really hope is that you know how to do this already, and I am boring you to tears. That's what I really, really hope. In the meantime, the way that I'm going to do this is I'm going to say negative 4 times c is negative 4c, and negative 4 times positive 2. Negative 4 times positive 2 is negative 8. That's it. So I'm always going to keep the sign with the number. And it just makes life so much easier. You can just distribute in one step, which is way, way better, don't you think? Again, the same distinction here. You can see this has a plus sign. I don't need to distribute that. So I can really just drop those parentheses. Negative 4 plus. These parentheses aren't really helping me out here. Oops. And so again, this is just combined like terms. Here's a C, a 1C. You can write the 1 or not write the 1. It doesn't matter. There's a C there. And then I have my like terms of a negative 4 and a positive 2. A negative 4 combined with a positive 2. 4 negatives and 2 positives are going to leave 2 negatives. And this is a great answer, totally fine. If you wrote C minus 2, that is also totally fine. If you wrote negative 2 plus C, that is also totally fine. All of these are the same. All right, a few more. Let's get a little bit quirkier. Again, I'm just going to speed this up a little bit. When a number is right adjacent to parentheses, it means multiply. So there is that little invisible multiply here. Again, if you need to pause the video, feel free to pause the video, rewind if you need to. It's totally fine. So we're going to distribute again this negative 2. And I'm going to make sure that I include the sign here. Make sure to keep it nice and neat. Don't get too messy with bunches and bunches of signs. Negative 2 times h is negative 2h. And negative 2 times negative 6. Think negative 2 times negative 6. Even number of negatives is going to have a positive result. That is going to be a positive 12. And you're done. That's all we can do. All right, down here. Ooh, distributing this here. We have a negative in front of parentheses. This is very, 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 very difficult. It's not difficult at all, actually, but this is where most students make mistakes. We do have to distribute negative signs. So what I like to do is think about this as like a negative 1. And in this case, this is a negative 1 right next to a set of parentheses, and I need to distribute that inside, okay? So you do have to distribute a negative. Could I have done the same thing before? I actually could have. I could have said, well, this is a positive 1, and I want to go ahead and distribute that. Well, if I were to distribute the positive 1, 1 times x is 1x. And 1 times 5 is 5. So you get the same thing. Now, with the negative, we're going to distribute this negative 2 way out in front. He's just chilling right out in front there. Negative 1 times h is negative 1h. And then I have negative 1 times the entire negative 6. Negative times negative is a positive. 1 times 6 is 6. So that's negative 1 times negative 6 gives me a positive 6 result. And from here, once we've distributed, so that was my first step, distribute. distribute the -1. Now we're going to combine like terms. And we use these phrases, distribute and combine like terms. This is this entire unit, ladies and gentlemen, so get used to it. First, anything with a variable, any letters in there, I have a -1h. And then I want to combine my plain old numbers, my integers. So -2 and a +6 is a +4 for the win. And this is a great answer. If you just wrote -h plus 4, that is equivalent. If you wrote 4 minus h, that is equivalent. Is h minus 4 the same? That one is not the same. In this case, that h is a positive and the 4 is negative. And that's not what these say. Here, the h has the negative and the 4 has a positive. And so as long as you take those signs in front, the signs to the left of the number or variable, those are attached. Think of them together. All right, this is kind of a weird way to write a distribute property, but it is. This 5 is right next to the parentheses. So this is also distributing. It's just distributing from the other side, if you will. So again, we are going to distribute. We're distributing the 5 this time. So 5 times 3 is 15. 5 times 2j. 5 times 2 would give you the 10. This is a great answer. All right, h looks pretty complicated. We want to know what we need to distribute. Do we need to distribute this negative? We had to distribute this one. It's kind of weird, right? This one we actually don't have to distribute. This is read as a subtraction. When it's in front of the parentheses, by in front, I mean on the left-hand side, we do have to distribute it. But here, we don't have to distribute positives and negatives from the left. If it was a 5 like that, we would, but not the negative. We do have to distribute this 2, however. 2 times 3 is 6, and then 2 times 2j becomes a +4. Whoops, j, there you go. And then we're just going to bring that -5 along for the ride and combine like terms. So I have my 4j to start us off, and then a +6 and a -5. There are far more positives. Positives are going to win by 1. Remember, whenever there's a sign, when there's no sign in front, it's positive. All right. +6, -5. Positives are going to win. That's it. Ladies and gentlemen, please, if you have questions, write them down. Highlight them. And again, you have IXL A3. So you can access that from the green IXL app in Clever, or you can just go to the calendar and click on the link and it should take you right there. And remember, do you see your name in the corner? And if you don't, you need to go back to Clever and click on the IXL link and make sure you see your name that way. So make sure you see your name, and you have to get a 85 would be fine. And then you can just leave the program. Okay. I will see you later. Have a great day.